Hello everyone, my name is Shamstan. Today I will talk about Monte Carlo simulation. Before passing to the video, I will give you a little outline what will I talk about in this video. Firstly, I will talk about the history of Monte Carlo simulation. Then I will talk about random walk or drunkard walk. Then I will talk about random number generator. Then hit and miss method. Then 95% confidence interval. Then Monte Hall dilemma. Of course, in the middle, I will talk about I will talk examples, because without example it would be very boring. And firstly, let's talk about a brief about history of Monte Carlo simulation. Monte Carlo simulation is very powerful probabilistic analysis tools because if we cannot think, or we cannot imagine every situation, but we can simulate it. It is named after famous gambling hotspot Monte Carlo. It is initially used to solve neutral diffusion problems in atomic bomb research at Los Alamos National Laboratory, and it is also most utilized tools have been during World War II. Let's pass to our first example, which we have promised in outline part. Let's talk about, we are tossing a coin. As you know, it is heads or tails coming percent is 50%. But when you toss 2 times or more times, heads or tails come out, and you can see that maybe the ones coming percent is not 50%, one is more, one is less. But when you simulate it a large amount of times, you can see that the frequency of one side heads or tails can close to 50%. For example, here we have simulated 100,000 times, and it is 50%, and this is hn minus 1 over 2n. Hn is number of observed heads, and 1 over 2n number of expected ends. And the difference between heads and tails coming out, it increases when number of simulations increase, and it is not something unusual. It can be explained with mathematical phenomena. It is in numbers distribution around 0 is with standard deviation square root of n in number of the simulations, and it's called also random walk. So from in this picture, you can see that when heads comes, we go 1 up, and tails comes out, it goes 1 down. When number of simulation it goes, it is less likely to come to the origin, the 0 point. It goes away from center. It is 2000 simulation has been done here. And then let's talk about random number generator. It was before random number generator. It was giving any initial value, and then getting multiplying that numbers with a, and then model m, and we're getting the random numbers. I mean computers, but as you know, it is not true random numbers. It was just computers the way. With this method, you can get numbers between numbers in range roughly 2 billion numbers. But then new ways came out. It is Christopher Columbus generator. You can see or Mersenne Twister generator. With the help of these generators, you can get a large amount of random numbers. Let's give an example to this random numbers. For example, what can we solve with random numbers? Of course, random number is the main part of these simulations. And for example, birthday problem can be best example for this. Let's say there are 10 people who lives together at home, whose birthday will be the same, or 1 day apart or 1 week apart from each other. about if there is 10 persons at home, let's say we are doing 100,000 simulations. After 100,000 simulations, the people who has one day apart birth is roughly 31.5%, and the people who have 1 week apart, their being birth is more than 86%. And this also a simulation can also help us to solve geometric problems. For example, hit and miss method can be example of this. Distance between two random numbers. What is distance between two random numbers? Let's take a unit square and unit circle. Unit circle which is radius is 1, and unit square which is side is 1. And we take random numbers inside this circle, inside the circle and inside this square. After doing simulation, we can get that the average, and we are each time we give two different numbers and x, y in this case, but in this circle case, x squared plus y squared less than 1, which sets y this point. We take those numbers, and then after, for example, out of simulation, we take average distance between all of them. It is this simple. And roughly average distance between, for example, here we have stated 1 million simulation has been done, and the distance between them is roughly 0.52, and for circle it is 0.9. Then let's come to this point, 95% confidence interval. 95. Let's say there are P is the probability with among n numbers S occurs. For example, let's say there are 25,000 simulations when in another birthday problems. Let's say there are seven people, and after in 25,000 simulation, you can set our confidence 95 confidence interval is roughly 120, and if we increase it 4 times 100,000, the confidence interval is roughly 60. And you can see that is from this formula. When number of simulation increases the effect of square root p minus 1 p, and decreases, and it becomes this fades out. It is effectivity, and when number of simulated increase 4 times, and interval decreases square root of decrease as square root of this. For example, it is increased 4 times, it decreased 2 times. Then at last part, let me talk about Monte Carlo Monte Hall dilemma. Monte Hall dilemma has become very famous in with respect to those. I forgot her name. It becomes very famous after the one TV show. Let's make a deal. It has begun. The person Marilyn was someone who took three-door problem. So according to this problem, there are three doors. And according to these three doors, one behind one door there are expensive cars, and 2 doors there is nothing. And TV host TV star asks the guest to choose one of the door, and guest to choose one of the door. After he proposes to change his option, and after this time Marlin was silent. insist on he should change his choice, but most of people who are not agreed with this choice, they say that the finalist player shouldn't change his choice, but even there was famous mathematicians who didn't agree also with this with changing the options, but after showing a simple simulation, they all agreed that choice should be changed. For example, there is a little simulation code. After let's say after 100,000 simulation, what will be our choice for these prize stores? It is we don't have that much time. I will not be able to explain this code, but let's run the code, or not like this. Let's see, it is 1 million range, therefore it can be a bit long. Let's see. As you can see, winning rate with don't switch strategy is 3, but winning rate with switch strategy is 6. And it's not something unusual, because when you don't change, as Merlin was someone who insists, your winning rate is 2/3, which is 2 times more than with not changing. And thank you very much for watching and listening my video. I hope my video is beneficial for you, and also in the description I will give detailed information about this topic. I had made this presentation from the book Surprises in Probability, 17 short stories, and thank you very much for watching.